Hi, I am Andrei Irag and I will be presenting our paper classifying land use and land cover around Lake Lanao. I will talk about what our objectives are and a quick background of Lake Lanao in the introduction. Next would be how this study was conducted and its details. I'll then discuss the findings and also recommendations based on those findings. This study aims to classify the land use and land cover around the Lake Lanao using the minimum distance algorithm and spectral angle mapping. Compare performance of different classifier models, and then discuss how classified LULC images can be used for future studies. The area of study will be the general area around Lake Lanao located within the Philippines. It's an ancient rift lake, ancient being approximately 2 million years old, and rift lake as being the product of tectonic plates movement. Its size is roughly 340 meters squared and averages 60 meters in depth. So let's talk about a little bit about its surroundings. This image combines administrative boundaries of Lake Lanao, a shaded relief map, and a gridded bathymetric map. It's observable that the area has three high altitude locations: Munay, Lumba Bayabao, and Maging. They are high altitude compared to the base area consisting of Marawi City and the area around Taraka and Tamparan, and of course Lake Lanao itself. So for our methodology, we use dark object subtraction for atmospheric correction for pre-processing. Explore the different Landsat 8-band combinations to see if there is anything that might be of note. Then we made independent training and validation sets. Model training using minimum distance and spectral angle mapping. Then after that, we evaluate the model by assessing the accuracy of the predictions. The software we used was Quantum GIS or QGIS version Brazeren and the SCP plugin which we use for training and classification. The data we used is from the United States Geological Survey or USGS, and we are grateful for their services. We explored the common band combinations from bands 1 and 7. We mainly used natural color, false color, and agriculture for identifying distinct classes from the data. We decided on using 6 classes for training and validation, which are vegetation, buildings or land use, water, bare soil, clouds, and cloud shadows. So after classification, we resulted in these two results. Looking closely at the spectral angle mapping map, we can see some white pixels mixed with the building or land use class. The resulting images were then assessed for accuracy with our validation set. We get these two matrices. Class 1 has the highest value since class 1 is vegetation and our area of study has a lot of vegetation. And second would be the land use class. From the observed low number of misclassifications, we can already tell that our models are performing well. So evidently, minimum distance performed better in classifying our data with an overall accuracy of 96.6% and a kappa value of 0.9318. The use of this data can be used in the following situations. For observing urban planning, we can identify areas suitable for development and zoning. For observing agriculture, we can monitor crops and identify land suitable for farming based on factors such as soil and climate. And then for prediction, I would actually advise future researchers to avoid using the resulting data from this study as it has some bias, like the classified clouds. I think introducing clouds to a prediction model would fail in a practical setting. That said, if you have satisfied the requirements, you can use LULC data for predicting urban sprawl and which areas are in need of attention. And then also predicting future environmental changes that would benefit farms in order to mitigate problems and increase the life expectancy of a farming business. That is all. Thank you.